Good day, everyone. Today we are going to start our classes on physics by using distance learning. So this today is first class. We will move to chapter 4, electricity and magnetism. So please open your book on page 170, magnetism, the topic of magnetism. What is a magnetism? So if we have like a compass needle is like a bar magnet, and when it's freely suspended and leave it rotate freely, it turns to point north south. One end of points or point is north like this. One end is point is north. This is the magnet is north pole or pole seeking north, and the other one is the south pole, which is direct to or mentioned to the south direction and known as north or south seeking poles. So there is two poles. This one is north one and this one is one. If the magnet is freely suspended, they will the two poles, they will lie like this, in S direction, in S direction. So a freely suspended magnet turns to so that it points to north south. As we can see here in this figure A and B, when the two magnets are brought close to each other, there is a force between them. So when the two magnets, like in figure A, is N magnet and NS magnet, brought close to each other, there will be a force between them. There is a force here. So the closed poles are N, they are same, N. And in figure B, they are different, N, S. So there is a force here. The force here will affect this direction, and the force between the different poles here in S, it will work in this direction. So the north pole of one will attract the north one. This one will attract the south pole of the other when they are different. But when they are same, they will repel each other. So the force here is a repulsion force. But the force here is attraction force. So as a conclusion from this figure, we can say that like balls, like those ones are repel each other, and the different balls or unlike balls attract each other. So what's magnetic material is and magnetization? Please turn in your book on page 171, and we will start with the topic magnetic material. So what's the magnetic materials? So if we take a compass needle, is like in a permanent magnet. It's a permanent magnet, like many other magnets. It's made of a hard steel. So a compass needle is permanent magnet, example of permanent magnet, and it is made of a hard steel. Most magnetic materials always contain iron. So if the material or materials contain significant amount of iron, it known as ferrous material. But if it contain lots or less iron, it knows as non-ferrous material. So we have two types of materials here, ferrous and non-ferrous. Ferrous materials, which mean contain lots or significant amount of iron, and non-ferrous material, it contains less iron. So what's a magnetization? Topic of magnetization. Magnetization. Usually magnetic material are in unmagnetized. Always magnetized state. And they must be magnetized. So here we are going to discuss four different methods doing this, or to get magnetization, or to bring magnetization to materials. And the four methods are listed here. First one, to do magnetization on any material or any kind of material, just take a piece of material and lie it down. So a piece of material may be struck with permanent magnet. So the first method to get magnetization is struck it with permanent magnet. If we use permanent magnet to struck any material, it will come magnetized. So by striking it consistently from one end, like here in this figure, if we struck it with permanent magnet, and by striking it consistently from one end to the other, this way, and then move your hand up and do it again. Move your hand up and do it again. So by this way, the iron wire here, it will come magnetized. But keep in mind, never going in reverse direction. If you move your hand in reverse direction, so you will lose magnetization. The second one, or the second method, place the material in strong magnetic field. So the second one is using magnetic field or strong magnetic field. First one is struck a material with permanent magnet. The second one is using strong magnetic field. Strong magnetic field are produced by an electromagnet. It becomes magnetized. So if you put any material in a strong magnetic field, it becomes magnetized. The third one is place along thin bias of material so that it lies north-south, and then heat it. If you put it north-south in the Earth's magnetic field and then heat it. So the third method is by heating material. It will have been magnetized by Earth's field. The last one, by hammering a piece of material, place it in north-south direction. If you put a material in direction of north-south, and then will pick up the Earth field. So the third one is by hammering material. The third one by using the field or magnetic field of Earth. The second one by using a strong magnetic field. The first one by striking the material. Here discussed, or magnetization. To get magnetization, we discuss four different types. Just for example, we are going to take 4 examples here to get magnetization. There is another ways, but just here in our class, we just mentioned 4 different kinds of or methods to get magnetization. So also material known as magnetic material may be classified as or known as hard and soft material, or hard and soft magnetization. So what's the difference between hard and soft magnetization or hard and soft material? As we can see here in this table here, the table here illustrates type of magnetic material, hard and soft, 2 types, hard and soft. So what is the description of hard? The hard material or the hard magnetization retains magnetism well. So it's magnetized very well, but difficult to magnetize in the first place. It's hard to get magnetized. but once get magnetized, it retains magnetism very well. Example of it, it's like a hard steel. So different uses here: permanent magnet, compasses, needle, and so on. The soft one is different from the hard one. It's easy to magnetize it, but lose its magnetism very easy. It's easy to lose its magnetism. Example of it, it's like soft iron. So there are two types of hard and soft magnetization. The difference is here. Keep those in mind, please. Now we will do the opposite. We discussed 4 methods to get magnetization. Now we are talking about how we can remove the magnetized from the material, or demagnetization. Demagnetization. So as there are several ways to magnetize a piece of magnetic material, also there are several ways to demagnetizing a magnet. 3 methods of doing this are illustrated here and called demagnetization are listed below. First one is hammer the magnet. Hammer the magnet. Second one is heat the magnet by using the heat, and this is the best one, by using the heat. 3. Place the magnet in field of electromagnetic. So first one, hammer the magnet. When a magnet is placed in east-west direction and hammer it, so put the magnet in direction of east-west and then hammer it. It loses its magnetism. The second one is heat the magnet. This is the best way, and the what do you call? I mean the element or the material or any. This one by using the heat magnet. So if the temperature goes above certain temperature, it will lose its magnetism or its magnetism. The third one, so the magnet here in number 2. Why is this the best way here? Because we're using the heat here. It's up to, for example, 500 centigrade. So this temperature is completely remove the magnetized or the magnetization from the magnet. We lose all magnetization. Number 3, place the magnet in field of an electromagnet. See below, we will see it in the figure. This is connected to an alternating current supply. So it's connected to AC current supply. The magnetic field will vary back and forth, back and forth, back and forth, and then will lose the magnetization. So this is the figure 16.5, which is placed a steel pin, which is discussed in here. We mentioned it here. So place the magnet in the field of electromagnetic that is connected to an alternating current supply. Number 4, or topic number 4, induced magnetism. So what is the induced magnetism? Always when we say permanent magnet can attract or repel another permanent magnet. So if we have 2 types of permanent magnet, like SN magnet and NS magnet, permanent and permanent, permanent magnet and permanent magnet, can attract or repel, attract or repel. It can also attract and magnetized magnetic material, another material. So it's not necessary to magnetize, another magnet. So we can use magnet to attract or repel or unmagnetized magnetic material. For example, if a bar magnet can attract steel pins or some small piece of paper, and the fridge magnet can stick to the steel door of the fridge. So what is going on there when the steel door or the fridge magnet can stick on the steel door of the fridge? What's going there? Steel pins are made of a magnetic material. When the north pole of a permanent magnet is brought close to a pin, the pin is attracted. So the traction tells us that the end of the pin nearest the magnetic pole must be magnetic south pole, as shown in this figure here, N and S poles. So this is known as induced magnetism. This is known as induced magnetism. When the permanent magnet is removed, then the pin will return to a magnetized state, or it may retain a small amount of magnetism. So that's all for today. We will see you next lesson, inshallah. Thanks.